In today's video, we are going to look at the argument of a complex number z. By definition, argument is the angle theta between positive real axis and the line joining the origin and z. So we have the Argand diagram with the real axis and the imaginary axis. Also z, it is given by x plus iy, meaning that z is a set of points x and y. Now we need to plot those points x and we need to plot y. We shall join those points and we shall have x and y. Now we say that the angle between the positive real axis, this is the positive real axis, and the line joining the origin, this is the origin, and z is here. So that is the line, and we need the angle between that. So it's given by the theta. And from trigonometry, we know from trigonometry, tan of theta is equal to y out of x, and theta is equal to tan inverse of y out of x. We should note that our argument lies between negative pi to pi. Is that okay? Therefore, the argument theta is less than. Are we together? Now let us go for examples. Example 1. We need to find the argument of z, where z is equal to a 5 plus 2i. So we shall sketch our Argand diagram. On the real axis we have a 5, and on imaginary axis we have a 2. So we need this angle, which is a theta, and we say that a theta is equal to tan inverse of the imaginary, which is 2, out of the real, which is 5, and the theta is equal to, what is tan inverse of 2 out of 5? Tan inverse of 2 out of 5. So theta is 21.801 in degrees. We need the argument in terms of radians. So theta is equal to 21.801 out of 180 pi. So theta is equal to 0.1211 pi. And we should note that this complex number of ours in the real plane. So we're going to have example 2. Example 2, it is telling us find the argument of z, where z is equal to negative 2 minus 2i root 3. So we need to sketch That is our Gantt diagram. This is the real and this is the im. So now on the real axis we have a -2. On the imaginary axis we have a -2√3. So joining points we shall have our angle theta like that. Now we need to find the argument theta, which is tan inverse. We say that it is the imaginary, which is 2√3 out of the real. As students, the reason why we take positives is because the -2 and the -2√3, they are just telling us that it is lying in this quadrant. For example, we know that it is the only third quadrant where we can find the negative on the x-axis and the negative on the y-axis. Now we need the theta, where theta is equal to 60 degrees. Now this is 60. It is between this negative real axis and the line. We need this angle, which is theta 1, as our argument. So our argument theta 1 is equal to this is 90 plus 30, which is -120 degrees. It is 120 negative because it is moving in the what? In the clockwise direction, and clockwise angles are measured in negative. So theta 1, which is our principal argument, is 120 out of 180 pi. So theta 1 is equal to 2 pi out of 3, but a negative. Example 3, z is equal to -5. So someone may say, that one is not a complex number, but in complex numbers that is a perfect complex number, because it can be written as z is equal to -5 plus 0i, and this z is purely real because the imaginary part is 0. So we can sketch our Gantt diagram. We have our real axis and our imaginary axis. So we have a -5 that side and a 0 on the axis. Now if we want to plot the angle, we shall move like this up to there, and this angle is going to be 180 degrees. So our principal argument is pi. Are we together? Let me hope that we are following. We have another simple example. It is telling us that we find the principal argument. We find the principal argument of z, which is -i√2 plus 1. So the first thing is we have to sketch, and our real axis is having a 1, and the imaginary axis is having -√2. So we need to find the argument, which is √2 out of a 1, and we said that theta is equal to tan inverse of √2. So what is the answer? Tan inverse of √2, so which is theta is equal to 54.7 divided by 1